Hello, Algebra 2. So today we're going to work on lesson 11.8, which is called binomial theorem. Hopefully the fractal video that I gave you went smoothly for 11.7, and hopefully that was a better solution than me trying to teach what fractal patterns actually are and how to dive into fractal math. Today's lesson on binomial theorem is split into really two chunks again. So lesson 6 was two chunks. We talked about recursive formulas and we talked about repeating decimals. Today our lesson is broken into two chunks. We're going to talk about fractals, or we're going to talk about factorials. We talked about fractals last time. We're going to talk about factorials, and we're going to talk about binomial theorem. I'm going to spend very little time on factorials and a lot of time on binomial theorem. But in the homework, there's a lot more factorial problems than binomial theorem problems because the binomial theorem problems take a lot longer. Now, hopefully I'm definitely only going to give you the easier binomial theorem problems, and moving forward, hopefully I'm going to keep it that way. So hopefully that keeps our stress level down on binomial theorem. It is one of the trickier lessons in the chapter, and it's a really important concept. But it's something that if we could just get a little bit into, we'll be okay. So I'm not going to dive deep into any of the really high level issue problems. I'm going to stay with the problems that only require us to go to like the 6th or 7th row of Pascal's triangle, and I'm going to try to stay away from any problems that have leading coefficients or things that might make them more difficult. All right, so let's start our discussion about factorials. A factorial is every integer from a starting point down to 1 multiplied together. So if I wanted 6 factorial, and the way that's written is 6 with an exclamation point afterwards, that would be 6 times 5 times 4 times 3 times 2 times 1. So 6 times 5 is 30, and 30 times 4 would be 120. 120 times 3 is 360. 360 times 2 is 720, and 720 times 1 is 720. So 6 factorial ends up being 720. Now, doing them out like this is as easy as anything. There is, however, a button on your calculator that allows you to do factorials. As we move forward into chapter 12, if we get into chapter 12, which we probably will if you're already watching this, you're going to need to be able to do these factorials much quicker there than you will have to now. So it isn't a bad idea to start practicing using the button in your calculator, even though it's just as fast to do 6 times 5 times 4 times 3 times 2 times 1. Most of you will find your factorial button under the option PRB on your calculator. Some of you will have an exclamation point right out on your calculator, either as a regular function, a shift function, or like a double push function, and that's great, use it. But those of us who are looking for it, you may be looking for it under the PRB button. If you have a graphing calculator, because I know a couple of you do, you want to go under Math, which is down the left side of your calculator, about 4 buttons or so, right under the alpha and the second button. And then if you click over to the right, eventually you'll get to a menu that says PRB, and that's where you'll find your exclamation point button. that PRB option is also where you're going to find a lot of the buttons we're going to need as we get into chapter 12. So it's really good to kind of have a feel for where all of those buttons are anyway, because we're going to be doing some NPR, NCR, and heavily working with factorials when we get to chapter 12, if we get to chapter 12. So it's a good idea to explore your calculator a little bit. If you're having trouble finding it, let me know. There is an exclamation point button on the calculators on the iPads, if that's your calculator of choice. But hopefully you all have a calculator beyond the iPad calculator sitting at home with you right now, and you didn't leave it sitting in your locker or something like that, because you're going to be much, much better off with a better calculator than just the regular iPad calculator. So hopefully there isn't any question here. I'm going to do one more quick example. Let's do 5 factorial. So 5 factorial would be 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. So 5 factorial is 120. In the homework that you're going to be working on today, you're going to be doing a lot of just basic factorials, and you're going to do some factorial, well, this factorial divided by this factorial multiplied by this factorial, but it should be really simple, basic work if you're working through it. Should be okay. Now we need to focus on binomial theorem. And so binomial theorem is an end around to saving some time with problems that are incredibly time consuming. It's important to understand that if you were to do this by hand, it would take you forever. Binomial theorem is not a short process. It's going to take time, but it is not going to take forever like it could. So I want to look at this first problem that I put up here, which is just an example, and then I'm going to do one of the homework problems for you. My example here is x plus 4 to the 6th. If I wanted to do this the old school algebra way, I would need to rewrite x plus 4 6 times and multiply it out. 2, 3, 4, 5, 6. X plus 4, 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 x plus 4. Now when they're even, you're better off than when they're odd, because they're worse when they're odd. Of course, after we have our even comparison, this one's going to turn odd. They're really, really nice if their powers of 2, but they're awful no matter what. All right, so I have 3 FOIL problems. The only nice thing about the 3 FOIL problems is that they're all the same FOIL problem. My firsts are x times x, which is x squared. My outers are x times 4, which is 4x. My inners are x times 4, which is 4x. And my lasts are 4 times 4, which is 16. I can put these middle two together to get 8x. So I end up with x squared plus 8x plus 16. Now, I wish I was done, but I'm not. That's just this first group of FOIL. Now I have to do the same for the second group and the third group, because I have 3 pairs of x plus 4s. The nice thing here is that they're all the same. So I have x squared plus 8x plus 16, and then I have x squared plus 8x plus 16. If I wanted to continue this forward from here, which I need to, I would have to multiply this trinomial by this trinomial. And then I have to take that answer, which will be a quadrinomial, and times it to this trinomial, making a giant, giant solution. Just to show you how awful this will get, I'll just start it. I need to take this and distribute in each piece to each piece of the second part. x squared times x squared is x to the fourth. X squared times 8x is 8x to the third. X squared times 16 is 16x squared. Then I would take and distribute in my 8x to everything in the second one. Then I would take and distribute in my 16 to everything in the second one. Then I would have to combine all the like terms to shrink it down to a quadrinomial. You can see that already this problem has become way more work than it originally looked like. We need a better system, and the better system is called the binomial theorem. Now remember that Mr. P said this better system still takes time. It is not a fast, easy process, but it is a heck of a lot better than this. The key to binomial theorem is to work with Pascal's triangle. I'm going to get rid of all this crap. Now, hopefully Pascal's triangle is posted somewhere. If it isn't, I'll get it to you, but I'm pretty sure it's in my notes on lesson 8. So pop open the notes for lesson 8 and grab Pascal's triangle, or just Google it. Google Pascal's triangle and you'll have it. And you usually get it down to like 10 rows. So that's going to cover anything we're going to do, because I think all the homework problems that I picked for this are going to be 7 or fewer. The row we want to go to is the row that corresponds with our power. Our power is 6, so we're going to go to row 6, which I've already laid out here, but I'm going to move up over to the side. Now I created Pascal's triangle to find row 6. You can just copy row 6 down from Pascal's triangle. Now the next thing we're going to do is we're going to do a snake draft of our two pieces in our binomial, back and forth across our Pascal triangle. And what Mr. P means by that is that we're going to do a sliding scale from the right side down to the left side, and then we're going to start back over and we're going to do a sliding scale from the left side down to the right side. Here's what I mean. We're going to take the first part of our binomial, which is x, and we're going to drop it on the first term. And then we're going to give it the same power that our binomial is to the 6th power. We're then going to move to the second term in Pascal's triangle, and we're going to put that same term, x, but this time, instead of being to the 6th power, we're going to drop the power by 1, down to the 5th power. Then we're going to move to the third term. We're going to put that same first term, but we're going to drop it down to the 4th power. X to the 3rd power, x to the 2nd power, x to the 1st power. And on the very last term, I don't need that first value at all. So I go x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st. No x's necessary. Coming up from the other side, I'm going to use the other term. Over here, I'm going to start with 4 to the 6th power. And then I'm going to work it downward the other direction. This one is going to get 4 to the 5th. This one is going to get 4 to the 4th. This one is going to get 4 to the 3rd. This one is going to get 4 to the second. This one is going to get 4 to the first, and this one is not going to get a 4. Now, if you have variables in both places, which some of these problems will, your process will be done right now. But which my next example will be like that. But because I have numbers, I need to clean my numbers up. This one is just x to the 6th. 1x to the 6th times nothing is x to the 6th. I'm going to put plus signs in between all the terms unless there's a negative here, which I'm going to do in my next example. I'll show you what to do. My next term says 6x to the 5th times 4. Well, 6 times 4 is 24, so that becomes 24x to the 5th plus. The next term says 15x to the 4th times 4 squared. 4 squared is 16, so I have 16 times 15, which is 240x to the 4th. Plus. My next term says 20x to the 3rd times 4 to the 3rd. Well, 4 to the 3rd is 64. I'm going to times that by the 20 that's already out front, and I get 1,280 x to the 3rd. Plus 15x squared times 4 to the 4th. 4 to the 4th is 256 times 15 gives me 3,840 x squared plus. My next term says 6x to the 1st times 4 to the 5th. 4 to the 5th is 1,024 times 6 would give me 6,144 x plus. The last term is 1 times 4 to the 6th. 4 to the 6th is 4,096. This becomes my solution. If I were to have continued that FOIL process that I was doing, this ultimately is where I would have ended up. Now, I would have ended up in tears on the floor, crying and screaming, long before I ended up here. But this is ultimately where I would have ended up if I had continued that process forward. Hopefully that makes some sense to everyone. We're on page 699. You're going to work problems 14 through 25. I'm going to go ahead and do problem 25 with you right now, just to give you a leg up on it. The vast majority of these are just factorial, so 6 factorial, 5 factorial, 9 factorial, whatever. But there are 3 binomial theorem problems at the end. I'm doing one of them with you here though, so I'm really only leaving you with 2. The binomial theorem problem we're going to work with is m minus a to the 5th. Now the nice thing about this problem is they give us both variables. So there isn't going to be much math involved. We don't have to multiply any numbers out or anything like that. The downside is the negative in between, which is why I put this in here, so that I could show you what you need to do when that happens. All right, let's kick into this. I need the 5th row of Pascal's triangle, which happens to be 1, 5, 10, 10, 5, 1. Look it up if you don't know it. Work it down if you want to. Okay? Now, down on this end, I'm going to start with my first term, which is m to the highest power, which is 5. Remember, I wanted my 5th row because of the 5th power. I start with my 5th power because I'm taking it to the 5th power. M to the 5th, M to the 4th, M to the 3rd, M to the 2nd, M to the 1st, no M's. Now I come back to my original, and I'm going to do my second term, A, but I'm going to start it down here. Now ignore the fact that it's negative right now. We're going to deal with that in a minute. A to the fifth, a to the fourth, a to the third, a to the second, a to the first, no a's. Now, here's how we clean this up because it's negative in between. M to the fifth minus 5m to the fourth a plus 10m to the third a squared minus 10m squared a to the third plus 5m a to the fourth minus a to the fifth. The technical reason that certain terms are negative is whenever my power on my a is odd, my term is negative. The real trick though is it's just every other term starting with the second term, because the second term will always have your first odd a. So it really doesn't matter that the rule is there because that power is odd, that it really just matters that you rotate. Positive, negative, positive, negative, positive, negative. Hopefully this goes all right for everybody. Let me know if it doesn't over email, Zoom, etc. Remember that this is the last lesson that we're going to work on for the chapter because it's the last lesson of the chapter 11. So moving forward, the next couple of things you're going to see from me are a review assignment, which comes out of the book, just like our normal review assignments do. I will have an expected, you must complete this many, and then an extra credit option beyond that. And then I will be posting a test, which is not a test. We're going to treat it like a worksheet. You can work through it with help from me, with help from your friends, with help from your parents, with help from your siblings. It doesn't matter to Mr. P. However you need to get help, you can get help. Come to me, get help on it, work through it, turn it in. It'll be worth 20 points. It'll go in as a test grade, but it'll really be more of a worksheet-based assessment. All right, I hope everybody has a really good couple of weeks because this might be the last time I communicate with you for a while.